For a resting neuron, the membrane potential is called the resting potential and is typically between -60 and -80 millivolts. If a depolarization shifts the membrane potential sufficiently, the result is a massive change in membrane voltage, called an action potential, which sends the signal down the neuron. The membrane potential then falls to the undershoot and returns back to the resting potential, around -70 millivolts. The red arrows show the flow of the signal from the dendrites to the cell body through the axon to the synapse and then on to the next cell body. The signal is passed from one cell to the other by neurotransmitters that pass through the synaptic cleft.
Depolarization. A stimulus opens the sodium channels and Na flows down the concentration gradient. Then the rising phase of the action potential. The falling phase, the K plus channels open and flow through their concentration gradient. And the undershoot, the sodium channels close, but some potassium channels are still open. An action potential is generated as Na plus flows inward across the membrane. The depolarization action spreads to the neighboring region. K plus moves outward. The depolarization-repolarization process is repeated along the length of the axon.
Cytoplasmic Na plus binds to the sodium-potassium pump. The affinity for Na plus is high when the protein has this shape. Na plus binding stimulates phosphorylation by ATP. Then, phosphorylation leads to a change in protein shape, reducing its affinity for Na plus, which is released outside. The new shape has a high affinity for K plus, which binds on the extracellular side and triggers release of the phosphate group. Release of the phosphate group restores the protein's original shape, which has a lower affinity for K plus. An action potential arrives at the end of the axon, depolarizing the presynaptic membrane. The depolarization opens voltage-gated channels, triggering an influx of calcium ions, which cause the synaptic vesicles to fuse with the presynaptic membrane, releasing neurotransmitter into the synaptic cleft. The neurotransmitter then binds to ligand-gated ion channels in the postsynaptic membrane. In this example, the binding triggers the opening, allowing Na plus and K plus to diffuse through.
Chlorotoxin is an amino acid peptide found in the venom of a Death Star scorpion. This comes and binds to ion channels in the cell membrane and blocks the entrance of chloride ions. This often causes paralysis.